Hello students, in this lecture we will learn about the radiation exchange within enclosed surfaces. Now what is an enclosed surface? Suppose this is a hollow sphere, you can see. So radiation exchange happening within inside inner surface of this hollow sphere, you can consider it as radiation exchange within enclosed surface, because the inside surface of this hollow sphere is fully enclosed. Radiations cannot go outside the sphere. Okay, similarly this is an enclosed hollow cuboid. Okay, radiation exchange happening between the faces of this hollow cuboid. This is the condition for radiation exchange between enclosed surfaces. Again, radiations cannot go out of this cuboid. Okay, similarly suppose you are in a room, okay, and room is closed from all of its side, means the doors are closed and the windows are closed. So the radiation exchange happening between the ceiling, the floor and the walls of room, you can consider it as the radiation exchange within the enclosed surfaces. So hope you would have understood what is an enclosed surface. Okay, now we will talk about the analysis of enclosure made up of black surfaces with same temperatures. Okay, black surfaces means what? That the surface, however we are taking the enclosed surface, but the surface from where the radiation is emanating, that is a black surface, a black body surface. And you know what black body surface is, which can absorb whatever amount of radiations which are falling over it, as well as it is a good emitter of radiations also, because good absorbers are good emitter. Second thing is, we will talk about the cases in which those enclosed surfaces are with same temperatures. Okay, now suppose these are two surfaces, this is surface 1 and this is surface 2, and radiation exchange is happening between the two surfaces. You can see some radiations are coming from the surface 1 toward 2 and some radiations are coming from the surface 2 toward 1. Okay, now in case this surface 1, you can see this surface 1 is very close to surface 2 and the surfaces are parallel to each other. In case surface 1 becomes like this, you can see the orientation is changed. In this case also radiation exchange is happening. Surface 2 is radiating toward 1 as well as 1 is also radiating toward 2. Okay, but in this case what you see, that the radiation exchange happening between the two surfaces, almost all the radiations are absorbed between the two surfaces. Very less amount of radiations are coming out of the system. Okay, but in this case what is there, the surfaces are oriented so that however the radiation exchange is happening between the two surfaces, but more amount of radiations compared to this case, more amount of radiations are leaving this system, the two surface system, to the environment. Okay, so why it is this? Which factor is controlling that? In case some radiations are coming from surface 1 and going towards surface 2, then if it is emanating some amount of radiations, how much radiations are absorbed by surface 2, it is controlled by which factor? It is called as view factor or shift factor. Okay, suppose I say that this is surface 1, okay, and it is black surface and it is at temperature T. Okay, so the total amount of radiations which comes out from this black surface, that is surface 1, also called as total emissive power, is equals to sigma T to the 4 according to the Stephen-Boltzmann law. Now the unit of this emissive power is what? Watt per meter square. In case I ask you the total amount of power coming out from this surface, so power will be in watts. So in case I multiply with the area of this surface 1, I will get the total amount of radiations which are coming from this surface in watts. Okay, now in case I ask you that how much radiations the surface 2 is absorbing, suppose I say that 100 units of radiations are coming out from surface 1, out of that how much surface 2 is absorbing, because some radiations are going away of the system and some are falling over surface 2. So this surface 2 is absorbing how much radiations which are coming out from surface 1, that is controlled by this factor called as view factor. Means this is the total amount of radiative power coming out from this surface 1, that is A sigma T to the 4. How much surface 2 is absorbing, we have to multiply with a factor called as view factor or shift factor. Okay, this view factor is a geometrical attribute. Okay, it depends upon the geometrical orientation of the two surfaces. Means in case some surface is emanating radiations, how much the other surface will absorb the radiation is depend upon what is the view factor associated with those two surfaces. Okay, so F₁₂ is telling the view factor of surface 2 with respect to 1. So the maximum amount of this view factor could be 1. Okay, means maximum to maximum what is possible? Whatever the amount of radiations which are coming out from surface 1 is absorbed by surface 2, maximum to maximum. and minimum amount of view factor would be 0. For example, in this case, the view factor of surface 2 with respect to surface 1 equals to 1, almost equals to 1. The reason being that both the surfaces are parallel to each other and very close to each other. So the chances of radiations to go out of the system are very less. Same thing is there. F₂ is also approximately equals to 1 because both are parallel to each other again. So in case we write F₁₂, that is also approximately equals to 1, as well as in case it is F₂, that is also approximately equals to 1. Now the amount of radiations which are absorbed by surface 2 emanating from surface 1 would be Q₁₂ into F₁₂ into A₁. A₁ is the area of the surface 1 into sigma into T1 to the power 4. Sigma T1 to the power 4 is the amount of total emissive power of the surface 1. Out of that, how much radiations are absorbed by surface 2? We have to multiply the view factor F₁₂. F₁₂ means the view factor of surface 2 with respect to surface 1. So Q₁₂ is this much. Similarly, this second surface is also emanating the radiations towards surface 1. So for that case, the amount of radiations which are absorbed by surface 1 emanating from surface 2 would be Q₂ equals to F₂ A₂. A₂ is the area of this second surface, sigma T2 to the power 4. Okay. Now in case both the surfaces are in thermal equilibrium, it means what? That temperatures of the two surfaces are same. Therefore, in case both the surfaces are in thermal equilibrium, then we can say that the Q₁₂ must be equals to Q₂. The amount of heat which is absorbed by surface 2 emanating from surface 1 must be exactly equal to the amount of radiations which is absorbed by surface 1 emanating from surface 2. So under thermal equilibrium, Q₁₂ must be equals to Q₂, and other thing is that the temperatures of the two surfaces must be same because those are in thermal equilibrium. So keeping the value in place of T1 and T2, we are keeping T. Okay. So Q₁₂ will be F₁₂ A₁ sigma T to the power 4 must be equals to the F₂ A₂ sigma T to the power 4 because T1 equals to T2, like this. Now we can easily cancel these two, that is sigma T to the power 4 and sigma T to the power 4. Ultimately what we are getting, F₁₂ A₁ is equals to F₂ A₂. This is called as reciprocity theorem. Okay, it means what? That in case two surfaces are in thermal equilibrium and both are radiating radiations toward each other, in that case F₁₂ into A₁ must be equals to the F₂ into A₂. And I told you how. Once again I am summarizing the thing, that Q₁₂ will be this F₁₂ A₁ sigma T1 to the 4, and Q₂ would be what? F₂ A₂ sigma T to the 4. Under thermal equilibrium what happens? The amount of heat radiated toward surface 2 from 1 must be exactly same to the amount of heat absorbed by surface 1 radiating from surface 2. So Q₁₂ must be equal to Q₂. Similarly, the temperatures of the two surfaces must be same. So keeping the values in place of Q₁₂ and Q₂, and also the temperature T1 T2 must be equal to T, so you can cancel out this. Ultimately you are getting this F₁₂ A₁ must be equal to the F₂ A₂. It is called as reciprocity theorem or reciprocity relation. Now what is the maximum value of view factor? The maximum value of view factor will be 1. I told you already, because if one surface is emanating 100 units of radiation, the maximum value of radiations which can be absorbed by other surface is 100. Okay, so maximum value of view factor is 1, it cannot be more than 1, and minimum value would be 0. Now one thing is there, can a surface have its own view factor? Yes, it could be possible. For example, this is a concave surface. Okay, such type of surface is called as concave surface. This is convex surface and this is flat surface. For the case of concave surface, the radiations which are emanating from all points of the surface, it can be possible the radiations are falling over its own surface. Okay, so in this case what will happen? We will write like this, Fii. If the name of this surface is I, then Fii is always greater than 0. Fii is always greater than 0 for the case of concave surface, because it could be possible that the amount of radiations which are emitted by it is falling over its own surface, because this entire surface can see itself. You can take it like this. But for the case of flat surface, whatever the amount of radiations which are coming out from this surface will go away. It cannot fall over its own surface because the radiations are electromagnetic waves, and electromagnetic waves always moves in a straight line. Same thing is there with convex surfaces. Whatever radiations which are coming out from this convex surface will go away, it cannot fall over itself. Only for the case of concave surfaces it could be possible, the radiations which are emanating from the points are falling over its own surface. So Fii for concave surface is always greater than 0, but Fii for flat and convex surface is always 0. Now suppose this is an enclosure of 5 flat surfaces, okay, and all the surfaces are black and are at same temperature, means the temperature of all the surfaces are same, okay. Now the amount of emissive power E₁₁ means what? The amount of radiations which are coming out from surface 1 and falling over itself, okay, is 0, because this surface 1 is flat surface, same like that of other surfaces. Surface 1 is flat surface, so E₁₁ is 0 because F₁₁ is 0. For flat surface F₁₁ is 0. Whatever is emanated from surface 1 will be absorbed by other surfaces, it cannot turn it back toward itself. Only for concave surface I told you that F₁₁ is greater than 0. What is E₁₂? Very simple, it would be F₁₂ sigma T to the 4. Sigma T to the power 4 is the amount of radiations which are emanating from surface 1. How much is captured by 2? It would be, we have to multiply with this geometric attribute, that is F₁₂, view factor of surface 2 with respect to surface 1. Similarly, E₁₃ will be what? E₁₃ will be F₁₃, it will be F₁₃ into sigma T to the 4. Similarly, in case there are n surfaces, then E₁n would be what? F₁n sigma T to the 4. Now, suppose I am considering, see, this enclosure is consisting of 5 surfaces, 1, 2, 3, 4 and 5. Now in case I am taking this surface 2, 3, 4 and 5 as a single surface X, surface 2 plus surface 3 plus surface 4 and plus surface 5, all these surfaces I am taking as a single surface, suppose the name is X. So in that case what will happen? E₁x will be what? Very simple, E₁x will be F₁x sigma T to the 4. The view factor of this surface X with respect to surface 2 is F₁x sigma T to the 4. Now F₁x will be equals to 1 because it is an enclosure. Whatever radiations which are coming out from surface 1 will ultimately absorbed by all these surfaces. We are naming it collectively as X. So F₁x will be 1. If surface 1 is emanating 100 units, all those 100 units are absorbed by these 4 surfaces. So we can say F₁x will be equals to 1. So ultimately E₁x will be equals to sigma T to the 4 itself. Okay. Now since the amount of radiations which are coming out from this surface 1 are ultimately absorbed by all these 4 surfaces, so in this case the algebraic additions of heat absorbed by all these surfaces must be equals to 1x or not, because E₁x is what? The amount of radiations which are coming out from surface 1 are absorbed by all these 4 surfaces. So the algebraic addition of the amount of heat absorbed individually by these surfaces must be equals to E₁x. So E₁x must be equals to E₁₁ plus E₁₂ plus E₁�5, because over here there are total 5 surfaces. Now putting the values in place of E₁x, I can write sigma to the 4. In place of E₁₁, I have to write 0. E₁₂, I can write this F₁₂ sigma to the 4. So keeping the values, I am getting ultimately this. So sigma T to the 4 can be cancelled. So ultimately what we are getting for an enclosure F₁₁ plus F₁₂ plus F₁�5, since it consists of 5 surfaces, is equals to 1. So in general we can say the F₁₁ plus F₁₂, in case there are n surfaces, ultimately F₁n must be equals to 1. It is called as summation rule. Okay, so we have learnt 2 rules. One is reciprocity theorem and other is summation rule for enclosure. Now we will solve some numericals to get better understanding in this regards. This is the cavity problem. Okay, this is a cavity, enclosed surface, cavity which is enclosed by the help of a lid, and lid is flat surface. Okay, and radiation exchange is happening inside this enclosed surface. So the problem is F₁₁ equals to what? Okay, the view factor of surface 1 with respect to itself. The amount of radiations which are emanating from surface 1 absorbed by itself. You can see this surface is what? This is a concave surface. This cavity is concave, you can see. And I already told for the case of concave surface, what is there? Fii will be greater than 0. So over here in this cavity problem, the radiations which are coming out from this surface 1, which is the surface of this concave surface of this cavity, how much radiations are absorbed by itself? So according to summation rule of enclosure, since this enclosure is composed of 2 surfaces, surface 1 and surface 2, so F₁₁ plus F₁₂ according to this rule must be equals to 1. Okay. Now with respect to surface 2 also you can write F₂₁ plus F₂ is also 1. With respect to surface 1 you can write F₁₁ plus F₁₂ equals to 1. With respect to surface 2 also you can write F₂₁ and F₂ must be equals to 1. Now F₂₁ is 1. The reason being F₂ is 0. Can you tell why F₂ is 0? F₂ is what? The view factor of surface 2 with respect to itself. Since this surface is flat surface, and for flat surface the own view factor is 0, so you can write F₂ as 0. So ultimately what we are getting? F₂₁ equals to 1. Now in case F₂₁ equals to 1, now we know by reciprocity theorem, we can apply reciprocity theorem also, because the surfaces are under thermal equilibrium. All the surfaces have same temperature. So these two surfaces have same temperature. So you can apply reciprocity theorem also. So A₁F₁₂ must be equals to A₂F₂₁. I already told you about reciprocity theorem. Okay. So applying that rule, that we have found F₂₁ equals to 1. So keeping the value over here, the value of F₂₁, what we will get? F₁₂ will be equals to how much? A₂ by A₁, because F₂₁ is 1. So F₁₂ from here we will get A₂ by A₁. So our first equation is this F₁₁ plus F₁₂ with respect to surface 1. This is the first equation. So keeping the value of this F₁₂ in place of F₁₂, what I will get? F₁₁ will be equals to 1 minus A₂ by A₁. Okay. So this is the view factor of this concave surface of cavity with respect to itself. That's it. So once again I summarize that F₁₁ plus F₁₂ equals to 1 by summation rule. Similarly with respect to surface 2 also, F₂₁ plus F₂₂ equals also 1. But F₂₂ is 0. The reason being it is a flat surface. So keeping the value F₂₁ equals to 1. Now since the surfaces are under thermal equilibrium, so A₁F₁₂ must be equals to A₂F₂₁. Keeping this value F₂₁ over here, so ultimately F₁₂ comes out to be this. So keeping the value of F₁₂ over here, I am getting F₁₁ equals to 1 minus A₂ by A₁. Now this is another problem, that there is a closed surface, you can see closed surface, and inside which there is some other surface. Okay. So between these two surfaces, this surface 2, this surface 1, the outer peripheral surface of surface 2 and the inner surface of the surface 1, this consists an enclosure. These two surfaces are forming an enclosure. So the question is, what is value of F₁₁? Okay. The radiations which are coming out from surface 1 are absorbed by surface 2, as well as some radiations are falling over itself. For the case of surface 1, some radiations are falling over itself. So the amount of view factor with its own surface is equals to how much? That we want to find out. Again, for an enclosure you can write F₁₁ plus F₁₂ equals to 1. Okay. With respect to surface 2 also you can write F₂₁ plus F₂₂ equals to 1. Okay. Again you can see this surface 2, okay, is a convex surface. This is not a concave surface, it is convex surface, and for convex surface the view factors of its own will be 0. So F₂₂ will be 0. So ultimately we are getting F₂₁ equals to 1. Again applying reciprocity theorem, because surfaces are at same temperature, thermal equilibrium. So A₁F₁₂ is equals to A₂F₂₁. So keeping the value of F₂₁ over here, we are getting F₁₂ equals to A₂ by A₁. Now keeping this value of F₁₂ in this equation, ultimately what we are getting? F₁₁ equals to 1 minus A₂ by A₁. By this way we have found the F₁₁. One more example. This is also an enclosure, a triangular enclosure, you can see, and the condition is this surface 1, this surface 2, this surface 3, and these two angles are same. This is angle X, this is also angle X. Means an isosceles triangle type of enclosure. Okay. Now question is, what is F₁₂ and F₁₃? Okay. So since this is an enclosure, so you can write this by summation rule, you can write F₁₁ plus F₁₂ plus F₁₃ equals to 1. Since this surface 1 is flat surface, so in place of F₁₁ we can write 0. For flat surface F₁₁ is 0. So ultimately what we are getting? F₁₂ plus F₁₃ equals to 1. But these two surfaces are symmetric to this surface 1. Surface 2 and surface 3 are symmetric to this surface 1 because the angles are same. Okay. So in this case, by common sense we can conclude that F₁₂ must be equals to F₁₃, because these are symmetric surfaces. Okay. So whatever radiations which are coming out on surface 1, okay, half will fall over this and half will fall over this, because the orientation of the two surfaces over surface 1 are almost same to same. It is something like that. So in place of F₁₃, you can write F₁₂. So what you are getting, 2F₁₂ equals to 1. So F₁₂ equals to 1 by 2, and same is equal to F₁₃. Okay. So for symmetric surfaces also, but like this way we can analyze. So hope you would have understood about the radiation exchange within the enclosed surfaces, provided the surfaces are black surfaces and under thermal equilibrium. Thank you.